So here's a problem on page 433. This is a problem dealing with discrete random variables, talking about the mean and standard deviation. The problem says we have Rotter Partners is planning a major investment. The amount profit X is uncertain but is a probabilistic estimate, and it's given by the following distribution. So we have this table, we have the profit, then the probability, you can see it right there, right? So we have different profits, 1, 1.5, 2, 4, 10, so on. We've got the probabilities attached with them, right? And so in part A, we simply need to find the mean profit X, and then we need to find the standard deviation of this profit. So how do we find the mean profit? Very simple. We take the profit times its probability and add them up, right? So to get this, we call this mu of X, and we simply take the profit, say 1, times its probability. We have a chance of about 10% to get a profit of 1. We're going to add that with the other possible outcomes. You could also get an outcome of, say, 1.5, and this would have a probability of 0.2. You could also get an outcome of 0.2 with probability 0.4, and an outcome of 4 with probability 0.2, and an outcome of 10 with a probability of 0.1. We add these up, we multiply, and you're going to get 3 million. You remember this is in millions, right? So what this means, to interpret this, it means that on average, every time we invest in this company, you're going to see an output of $3 million. Sometimes you'll have less, sometimes you'll have more, but on average, it's 3 million. The standard deviation, we first need to find the variance in order to do this. So we call it sigma squared of x. And to get the variance, what we're seeing is we want the variation that's squared from the mean times the probability of this happening. So for the first outcome, 1 million, how much does this deviate from 3 million by? That's simply the question of answering 1 minus 3. We're going to square this too because we want to think of positive deviations only, not negative, right? So we want to think in maybe absolute terms here. So we're going to do 1 minus 3 squared, and then the likelihood of this happening, again, is 10% or 0.1. We're going to do this with the other outcomes too. So we have 1.5 minus 3 squared with an outcome likelihood of 20%. We also have 2 minus 3 squared with an outcome likelihood of 0.4 plus 4 minus 3 squared, probability 0.2, plus 10 minus 3 squared, this is the large one, and then with a chance of 10% of that happening, okay? We add this up, we multiply, we square, all of that great stuff. We're going to get 6.35, but keep in mind too that if, say, we wanted just the standard deviation of x, we're not quite done yet. The variance is very close, but all we have to do is just take the square root of the variance. And when we do that, we're going to get a value of 2.52 million. So that means that for a probability distribution given this variable x, it has a mean of 3 million, it has a standard deviation of 2.52 million. Now the good news is we can start thinking about probability outcomes. We can build a probability model, we can talk about the likelihood, say, of getting a profit of 10 million, or say the probability of getting maybe like less than 7 million, and lots of different questions that we can answer now with this model. Okay, so let's move on. Now they're going to add a little bit of complication here. They say Rotter Partners owes its source of capital fee of $200,000 plus a 10% of whatever the profits they make with X. So the firm actually retains this new value Y, which is really 0.9x minus 0.2 from the investment that they take. We need to find the mean and standard deviation of Y based on this. So notice what happened. When we take Y, Y is really just some sort of linear combination of X. It's some sort of linear transformation. I'm going to take X and multiply really a slope, right, 0.9, and then really we have like a Y-intercept, if you will, of negative 0.2. So when we have this linear transformation of X to produce Y, what happens? There's some useful equations to help us here. So if we want the mean of a linear transformation on X, the mean or the mu of A plus B of X, what we're really going to do is we're just going to add A times B and the mu of X, which is intuitive, right? Like if we have, a mean of 100 and we're going to take 90% of it and subtract away, say, 10, well, we would expect to get 80 because we just simply transformed as we directly saw it. Simple. There's one formula, though, that's not so intuitive. That's the variance of a linear transformation. So if we have sigma squared of A plus bx, amazingly, you're just going to get B squared times the variance of x with no a. There's no a in that formula. In fact, a has no effect on the variance. But, it's not too hard to think about if you really do put some thought into it. Basically, if you're adding a to every single value in your probability model, nothing really changed. If they all change by the same amount, it also implies that they don't change at all. So actually, even though it doesn't seem intuitive, it really, maybe makes sense if we think about it just for a second. Okay, good. So we have the formulas. We know what to do. So we're going to run the transformations. If we want mu of y, okay, this is a linear transformation. What we're going to do directly is just take 0.9 times the mean of x that we already found, right? And then subtract 0.2. So what is this? This is 0.9 times 3, right? Minus 0.2. And you're going to get 2.5 million. And that's the expected value after we take away all of the fees. Okay, what about the standard deviation? Before we find the standard deviation, let's find the variance. So we're going to find the variance of y, which is really just going to be b squared times the variance of x. And remember, again, b squared would just be 9 squared. The variance of x would be, let's see, it would be 2.52. Okay, and when we crunch this, we should get 2.04 million for our variance. And we're almost done. We just need to make sure that we get the standard deviation and not just the variance. The standard deviation is simply the square root of the variance. And so when we take the square root of 2.04, we should get 1.43 million. Okay, so now we have a new probability model. We have a mean of 2.5 million. We have a standard deviation of 1.43 million. And now we can again make that nice bell curve, right? It's centered on 2.5, and it has the standard deviations of 1.43 on either side that we're adding. And so we can build any sort of probability question that we want, and this will allow us, again, when we get into inferencing and we see how we can use this information to maybe make larger conclusions from the probability model, we'll find that these transformations are very useful.